Question number 1 says, does a car's speedometer measure speed, velocity, or both? Hence the name speedometer. Okay? What would it have to show to be velocity? Direction. So if you include the compass that comes in many newer cars, you would certainly figure out the velocity, right? But the speedometer itself is just speed.
Really should be doing that all the time.
What?
Trying to figure out.
Well, it's just like looking at the speed and then, oh, I'm going north. Like, I mean, add north on. You can change the channel and change the song on the radio on the stereo. I think you can probably just look at the.
Physics not sure. Physics not sure.
I'm not asking you to draw a scale diagram while driving. I would not recommend that. If an accurate speedometer registers a constant value for a period of time, can you determine the average velocity over that period of time using your own speedometer? This is the same question. No, of course not. Answer is no. Can the average velocity of a particle be 0 over a given time interval if it is not 0 over a shorter period of time? This one's a little more challenging. I'll read it again. Can the average velocity of a particle be 0 over a given time interval if it is not 0 over a shorter period of time? What do you think? Jake says yes. You say no. How many people say yes? Hands up. Small number. How many people say no? How many people want to change their answer now they've seen how many hands go up? No one. Correct answer is number 3 is yes. What if the object is traveling in a circle? Exactly. What is the average velocity for the entire trip? Big fat 0, right? Whereas the average velocity for a shorter period of time, say a quarter revolution, would be much different. It would actually have a numerical value. So yes, Jake and his small band of people is correct in this case. Number 4, can an object have varying velocity if its speed is constant?
No.
Just to be different, Dan says no, but he's wrong once again. Sorry. Yes. I think he just said no to be different, but he knew the answer was yes, right? Yes, he's agreeing with me. Yes, again, if you're traveling in a circle, right? Or if you're going around you got the cruise set, you're going around the big curve there at St. Rose. That's an example. We've talked about this. Number 5. Can an object have varying velocity if its speed is constant? Did I just do that one? That's number 4. That's the one I just did. Number 5. Can an object have varying speed if its velocity is constant? No. The answer is no. If the velocity is constant, then what? The speed and the direction are the same, right? So the answer to number 5 is no. Number 6, when an object moves with constant velocity, does its average velocity during any time interval differ from its instantaneous velocity at any instant?
Yes.
Just to be different, right? 6 is no. It is not a bunch of junk, Mike. 6 is no. Okay? Why? When an object moves with constant velocity, does its average velocity during any time interval differ from its instantaneous? No, constant velocity means it's always the same, right? That's what it means by definition. That's what it means. Number 7, can the velocity of an object, I'm going to do this because I'm getting lost. There we go. Can the velocity of an object be 0 at the same instant its acceleration is not 0? Oh, I don't have a bunch of people jumping up at this one. It must be hard. What do you say, Brandon? You say no? Oh, but she's not sure. Can the velocity of an object be 0 at the same instant its acceleration is not 0?
Yes.
What if I were to take a tennis ball and to throw it up in the air? At that very instant right there, what is the velocity? 0. What is the acceleration? It's 9.8. So in other words, the answer is yes. Huh. Did you erase the right answer?
No, I just said it differently.
Oh. Okay. Let's move on to number 8. If a car has a greater maximum speed than another, does it mean that it also has a greater acceleration? Correct that. No.
I don't know.
All it means is that it has a higher top speed, right? Exactly. So acceleration doesn't have anything to do with maximum speed. Compare the acceleration of a motorcycle that accelerates from 80 to 90 with the acceleration of a bicycle that accelerates from rest to 10 in the same time. They are equal. The same. Equal. Exactly the same. Number 10, can you conclude that a car is not accelerating if the speedometer indicates a steady 60 kilometers an hour?
Yes, that's right.
How come? Going around a curve, exactly. If you're going around a curve, what is the speedometer going to show? 60 kilometers an hour, but you are accelerating. And I think I did talk about this, right? Which way is the acceleration?
To the right.
Towards the center of the circle.
Well, but still.
Is that what you meant?
Yeah. If you're in a car, it's to the right.
What if you turn left? Okay. You just said if it's in a car, it's to the right.
Oh.
Car always accelerates to the right. Number 11, can an object have a northward velocity and a southward acceleration?
Yes.
Yes, absolutely. If it's slowing, right? If the speed is decreasing. Does that make sense? Stop me if I need to explain more.
Would a throwing a ball be a good example of that?
Sure, right. Yeah, absolutely, right. You throw a ball northward, and eventually it slows down due to air resistance. Same thing, right? As long as something's going north and slowing down, then that fits this criteria. Can the velocity of an object be negative when its acceleration is positive?
Yes.
Absolutely. What about vice versa? Absolutely. Again, just slowing down. Do you get the feeling that they're repeating the same concept, just worded differently all the time? Well, they're not trying to trick you. They're trying to make you realize, understand the different situations, right? But the concepts are the same. Give an example where both the velocity and acceleration are negative. That's actually quite easy. It's when the object is doing what?
Speeding up back.
Speeding up backwards, or just plain old falling, right? Drop a tennis ball, acceleration is down, negative, velocity is down, negative. That's easy. Speeding up backwards, downhill is true as well. Okay. I think here's where things start to get a little bit more challenging, right? Number 14, a rock is thrown vertically up with a speed v from the edge of a cliff. A second rock is thrown vertically downward with the same initial speed. Which rock has the greater speed when it reaches the bottom of the cliff? Ignore air resistance. Let me draw a picture of this. Here's a cliff, right? And the rock is thrown vertically upward with a speed v, and then the second one is thrown down. So let's just give it a speed just so that it's easier to talk about. 10. In the second instance, it's thrown down at 10. And the question is, which one has the greater speed when it reaches the bottom of the cliff?
The rock that's thrown out.
Which one's going faster when it hits the bottom? What do you say, Daddy?
The rock that's thrown out.
You say rock, we'll call them A and B.
Okay.
You say A is going faster when it hits the bottom? What is your logic? So it has more time to accelerate. Okay? How do people want to jump in there with that? He's saying that because this one, would you all agree that this one's in the air longer? I think everyone should agree with that, right? He's saying that because of that, it's accelerating more, it's going to be going faster when it gets to the bottom.
But wouldn't it just depend on the initial speed? Because I mean, like the one where he just throws it straight down, if there's no air resistance, it'll just keep accelerating. So
Isn't this one also continuing to accelerate?
until it's the ground.
Yes.
It has to start from zero. If the beam is thrown at the high enough initial velocity, then it just keep
They're the same, right? This one's 10, and this one's 10. Now, maybe I should clarify. This one's positive 10, right? And this one is? Maybe I'll put it in red. This one is what? Minus 10, right? You'll notice that I haven't agreed with him yet. How fast is A going right there? If there's no air resistance, it goes plus 10, and it goes plus 9, plus 8, plus 7, all the way to 0, and then it goes 1, 2, 3, 4, minus 1, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. How fast is it going right there? Is it not going minus 10 right there? So they are going the same speed. Sorry, man. He's absolutely right. This one has longer to accelerate, but it also has to go from positive to 0 and back to negative. In fact, they are both going to land at exactly the same speed. When I explain it that way, does that make sense? Which one's in the air longer? Clearly A, right? There's no doubt about that. Eh?
Can I get a cookie for time?
You know what? Your logic was good. It just wasn't complete. I don't have any cookies, sorry. Okay, number 15. Is this the one, Chris, you and I were talking about? Ball thrown vertically upward returns to the thrower's hand. Which part of the journey requires the longer time, upward or downward? Is this not almost the same as 14? You've got a stick figure person who throws a ball in the air like so. Right? And the question is, which one has the longer period of time? If there's no air resistance, is it the up or the down? Clearly they're the same. Right? If there's no air resistance, it's clearly the same. Now, what about if there is air resistance? This is up, and this is down. So if there is air resistance, let's draw in gravity in both of them, and both of the gravities are equal to minus 9.8. I think you'll all agree with that, right? Okay. Which way is the air resistance on the way up? Chris said down. Let's assign an air resistance of minus 1 just for easy figure. Which way is the air resistance on the way down? Up. Okay, so what is the overall acceleration here? Minus 10.8, right? So in other words, it's slowing down at a rate of minus 10.8. What's the overall acceleration on the way down? Acceleration. It's going to be minus 8.8. So in fact, it's slowing down faster on the way up than it is speeding up on the way down. So the question remains, which one takes longer? Is it not? Is that not the question? Yes. Which one is longer? Down. Has to be longer, right? Let me check my logic here. Yes, it must be longer down. How come? Because it's not speeding up as fast, right? It takes longer to cover that distance. Yes, I know it hurts your brain, but it hurts mine a little bit too. I'll pause there for a second. How fast is it slowing down on the way up? What's the number? Minus 10.8. It's slowing down pretty quick, right? In other words, it gets to 0 in a short amount of time. On the way down, it's speeding up at a slightly slower rate, right? So does it not take longer to cover that time period, that distance? It's the distance up has to be the distance down, right? That's a given. So if it's going slower, it's going to take longer. Yes, I know. Hurts the brain. Let's just leave it with 16 here, and then we'll call it a day. So 16 says, an object that is thrown vertically upward will return to its original position with the same speed as it had initially if air resistance is negligible. If air resistance is appreciable, will this result be altered, and if so, how? So now they're asking about the speed. Which of these will have, let me just reread this here. An object that is thrown vertically upward will return to its original position with the same speed as it had initially if air resistance is negligible. What does negligible mean? So small that we're going to count it as 0. If air resistance is appreciable, which means that it's a significant amount, will this result be altered? Will the speed be any different?
Yes.
It's the same kind of concept, right? But it's a slightly different, right? So which one is it? Will the result be different? Will it be going faster or slower than you threw it up with here? I'm going to double check my notes to make sure I get this right. Is that okay? If I don't look like I've got it memorized? Well, I could guess, but it would be one or the other. My notes tell me that it is slower on the way down. How come?
Air resistance.
Air resistance is preventing it from traveling faster, right? Preventing it from traveling faster. Now, again, depending on the object, like if you're throwing, like a coffee filter up, the air resistance is going to be like, as a percentage, going to be a huge number, right? It's going to slow down right away. So to see that, like to demonstrate that would be very challenging. You have to find an object with air resistance is significant enough that it would make a difference that you can actually throw up and it would go up a distance, right? And then measure on the way down. It'd be a little bit challenging, I think, to measure. Something for the Mythbusters to check out. Okay. Should we do 17 and 18 together, kind of thing? No?
Sure. You should transform them into opposite that.
We could do that. You know what? How about I save those for tomorrow? I will give you 17 and 18. If you want to turn it into the other draft question, I'll give you the answer tomorrow. That sounds like a good idea, Randy. And then there are some problems there as well. Okay? I will point out, like questions 1 to 4 are pretty simple. I really hope you can do those, right? 5 to 7, 5 to 8 are a little more challenging. Number 9 is quite challenging. Okay. For sure, you should try 15. Put 15 on your for sure list. That's all the ones that sort of jump out at me as ones that you should do. So give those a whirl. Spend some time doing some problems. We'll do a sort of another check on things tomorrow.
Same time, 9:30?
Yeah, I think so. I know quite often I do some examples from the textbook as well. I'll sort of take a temperature check at 9 tomorrow and see where we're at. I may do textbook questions tomorrow. Tomorrow's Wednesday, right? And then give you sort of like the remainder of Wednesday, maybe Thursday, sort of work on problems. So we'll sort of see how far you've gotten on these guys tomorrow.